Welcome. I'm going to attempt to give you some steps to solving some basic stats questions for BAS120 Chapter 7. So the normal steps are, first you'll establish what your null hypothesis and your alternative hypothesis. And remember, it's kind of like legal system. The null is the current state, and it's kind of like you're assumed to be innocent. So we assume that it's the normal state. And then you have to, just like in the legal function, you have to prove in your alternative, what you're trying to prove, that it's not the norm or it's not the status quo. So you have to prove, just like in a court of law, that they're guilty. The null hypothesis is kind of you're assumed innocent. The status quo is assumed. You've got to prove something different than the status quo. Second thing is we'll have to determine what kind of distribution we're dealing with. In this chapter, we're dealing primarily with t-distributions, normal distributions, and proportions, and I'll show you how to do each one of those. Next, you've got to calculate, well, if I did a test, where does my test statistics fall? What you're basically trying to do is you're trying to determine how far away from the mean is my standard on some sort of standardized basis. So you're going to take, in each case, the distance from the mean, and you're going to divide it by the standard error. And it's going to be slightly different for different distributions, and we'll go through that. But I want to emphasize the theme is all the same. Then you're going to calculate critical values. Is it far enough away from the mean for me to disprove the null hypothesis? A lot of that's going to depend on what your alpha is, or what the confidence level, 95% confident, 99%. What level of confidence do you want to have? And Excel has some interesting tools. It's basically the family of INV tools. Now for T, it's TIMV. For normal, it's NormINV. For proportions, I'll go through all of them. It's norm.SINV. But INV will basically help you determine what the critical values are. An alternative way is to calculate the p-value, which will tell you exactly the probability of the event of you getting that sample. Excel has a whole series of family of dist functions. And the last step is based on what you get for your test statistic. If it falls outside the range of the critical value, then you reject the null hypothesis. If it's within the critical ranges, then you do not reject. And p-values, basically, if it's a very low p-value, like the probability is only 1%, if you're getting this by chance, you'll generally reject the null hypothesis. So let me I tried to put all of these on one piece of paper for you. What we're trying to do in this chapter, now there's going to be more distributions as we get more into it, but right now we're dealing with a normal distribution, a t-distribution, and a proportion. So a normal distribution is when you know the mean and you know the standard deviation of the population. Now in real life, this is very, very rare. The t-distribution is similar to the normal, except the standard deviation of the population is unknown. So as a substitute, we say, well, let's use the sample standard deviation, because we'll know what the sample standard deviation is because we took the sample. The last type of distribution is a proportion. That's where you basically have binary results: pass, fail, yes, no, made, missed. Now it gets a little more complicated that we'll go into in future lessons. You have to make sure your events are independent. You have to make sure you have a large enough sample. But for right now, let's just assume that we can use the proportion when we have binary results. And we'll get into more how to test for independence and to make sure it's large samples a little bit later on. Now a test statistic is basically the same for all three. That determines basically how far away from the mean on a standardized basis, by dividing the distance by the standard error, are we from the mean. Here are the different test statistics for each one of the different distributions, and I'll go through a little bit of why they are, and they're not quite as daunting as they look. And then for Excel, the critical values, we can use NormINV. For t-distribution, TINV, norm.S. For the par values, the p-values, we use the disk family. And I'll go through those when we do an example. But here's a curve, and whether it's a normal curve or whatever curve it is, what we're trying to do is we're trying to say, well, our test statistic, how far away were we from the mean, and how far were we on a standardized score, and is that beyond our critical values, which would cause us to reject, or is it within our critical values, which would cause us to accept the null hypothesis? So the whole thing we're trying to do is say, let's take our sample, let's see what our sample average was, let's see how far away from the mean it is, let's standardize it by what's called a test statistic, and then let's see if that test statistic is within an acceptable range or outside an acceptable range. And will allow us to prove statistically whether our null hypothesis is true or whether we accept or reject. Well, no, I shouldn't have said true, because so let's talk about the normal distribution, because these equations look pretty incredibly daunting, but they really aren't that complicated. In every one of them, the numerator is telling us, the numerator is the top part, the numerator is telling us what's the absolute distance from the mean. Well, I take x bar as my sample mean minus mu, my population mu. So that's how much different my sample was, whether I'm sampling for daily sales or whatever I'm sampling for. How far away was from my sample from what I assume my mean is, divided by the standard error. Well, the standard error for a sample of 1 is the standard deviation. But remember, we learned as we do more and more and more samples, we're going to shrink that standard deviation, right? We're going to get more consistency, less dispersion. If I take a sample of 100, I reduce that risk of dispersion. So my standard error is going to be my standard deviation divided by the square root of n, where n is my sample size. So the more samples I have, the more consistency I get in my results, or the more faith I have in the results. So all this is this test statistic, which in this case is called a z, is the absolute distance from the mean divided by the standard error. Same thing for a t distribution, except the only difference between a t distribution and the normal is we don't know what the standard deviation of the population is. So we say, well, we'll put in the standard deviation of the sample. Now, the only trick statistically, and it's a minor thing here, is you need to understand anytime you don't know one of the parameters, and a parameter is just the population statistic, anytime you don't know that and you say, I'll substitute in a best guess for the population standard deviation, which is basically what you're doing. You're substituting in a best guess. You're adding more subjectivity to the equation, and that's why you need to add a degree of freedom. So there's 1 degree of freedom in this, but it's basically the same. And then for a proportion, it's p hat. I couldn't figure out how to get the little hat on this guy. And the book has the p hat minus what the assumed proportion is. So if I'm a foul shooter, 80%, and if I assume I'm 85%, down here I don't really have a standard deviation if you think of it, but this is kind of interesting. If you think of a foul shooter, and let's say they make 99% out of 100, there's very little deviation of that, as opposed to say a 50% foul shooter. So what this does, it takes the population proportion, and then 1 minus the population proportion, multiply those two together, and then again divide by n, because as the sample size goes up, we'll get less and less dispersion. So those are the test statistics. Those are how we use them in Excel. I'm going to stop now, and then we're going to go through 3 examples, so hopefully it'll be even more clear. Thanks. Let me know if there's any questions.